All right, welcome to the Explainer. Today, we are tackling one of the most powerful and honestly most important concepts in JavaScript, how it handles time. So in our last Explainer, we looked at execution context, the who that's running the code. Now, we're going to shift our focus to the when. This is all about how JavaScript deals with tasks that don't finish right away. And trust me, this is the secret sauce that makes modern websites feel fast and interactive instead of clunky and slow. So, to really understand why we even need to talk about managing time, you first have to get your head around a fundamental and kind of weird fact about JavaScript. It can only do one thing at a time. Yeah, that's right. This one-at-a-time approach is called synchronous programming. The best way to think about it is like a single file line. Each line of your code has to patiently wait for the one in front of it to finish completely before it gets its turn. No cutting, no multitasking. Now let's look at where this becomes a real problem. Imagine you have a function that has to do some heavy lifting, like calculating a huge list of prime numbers. That's going to take a few seconds, right? Well, while that function is chugging away, JavaScript's single-minded focus means everything else on your web page just stops. And this is a total disaster for the user experience. While that function is running, the entire web page is frozen solid. The browser is completely blocked, the user can't click buttons, can't type into a form, they're just stuck staring at a dead screen. It's awful, and it's the exact problem that asynchronous programming was invented to solve. Which brings us to the central question of this whole explainer. If JavaScript can only do one thing at a time, how on earth does it handle things like fetching data from a server or running complex calculations without bringing everything to a screeching halt? The answer lies in a super clever system called the event loop. This is the secret mechanism behind JavaScript's ability to juggle multiple tasks without actually being multi-threaded. Now, it's really important to realize that JavaScript itself doesn't have these powers. The magic actually comes from the environment it runs in, usually a web browser. The browser gives us the JavaScript engine with its call stack, but it also provides all these other pieces: web APIs, a callback queue, and the real star of the show, the event loop. Okay, this breaks down the whole dance. When you call an async function like setTimeout, it gets put on the call stack for a millisecond. Then it's immediately handed off to a web API in the browser. The browser takes care of the timer, which is great because the call stack is now free to do other work. Once the timer is up, the browser puts your callback function into the callback queue. Meanwhile, the event loop has one simple job. It's constantly watching the call stack. The instant the call stack is empty, the event loop grabs the first thing from the queue and pushes it onto the stack to finally be executed. It's a beautiful, elegant, non-blocking system. But wait, there's one more layer here. It turns out there are actually two different queues. There's the main one for what we call Macrotasks, that's things like setTimeout, and then there's a special high-priority express lane for Microtasks, which is mostly where promises live. The rule is simple. The event loop will always process every single microtask in its queue before it even thinks about looking at the next macrotask. In short, promises get to cut to the front of the line. So we have this amazing system. But how did developers originally manage all these asynchronous tasks? Well, the first solution was something called a callback. At its heart, a callback is just a function that you pass to another function as an argument. It's basically a way of saying, hey, when you're finished with your long task, please run this piece of code for me. And for a very long time, this was just how you handled asynchronous stuff in JavaScript. Now, the problem really shows up when you need to do several asynchronous things in a specific order. You fetch some data, and then when that's done, you fetch more data. And then when that's done, you do something else. You end up nesting callbacks inside of other callbacks, creating this sideways pyramid of code that just keeps indenting further and further to the right. This ugly pattern is famously known as callback hell, or the pyramid of doom. And as this quote says, it's not just that it looks messy. It's an absolute nightmare to debug and maintain. Trying to handle errors in a structure like this, forget about it. Thankfully, the community and the language itself evolved to fix this mess. So let's look at the modern solutions that were created to rescue us from callback hell, starting with promises. A promise is, well, it's exactly what it sounds like. It's an object that acts as a placeholder for a value you don't have yet. It's a promise that your code will get you either a result or a reason why it failed at some point down the line. Every promise goes through a simple life cycle. It starts out as pending. Then the async operation either succeeds, which moves the promise to a fulfilled state, or it fails, which moves it to a rejected state. And once it's settled, it's done. That state is final. And this slide right here shows exactly why promises were a huge deal. They take that nested, hard-to-read pyramid of doom and they flatten it into a clean vertical chain of dot-then calls. Each step in the process is its own link in the chain, making the logic so much easier to follow and to debug.
But the evolution didn't stop with promises. Building right on top of them, JavaScript introduced async and wait. This is what we call syntactic sugar. It just makes writing asynchronous code even more intuitive.
I mean, just look at this comparison. With async await, you get to write asynchronous code that reads just like normal synchronous code. The await keyword basically just pauses the function until the promise resolves, all without blocking the main thread. You can get rid of the .then callbacks and just use standard try-catch blocks for errors. It is, by far, the cleanest way we have to write this stuff today. So let's just recap the journey here. We started with callbacks, which were functional but led to messy code. Then came promises, which gave us a clean, chainable object to represent a future value. That evolved into async/await, which lets us write async code that looks synchronous. And underneath it all is the event loop, the browser mechanism that makes this entire non-blocking system possible. So what's the big takeaway? It's that JavaScript achieves the illusion of multitasking without ever actually running code in parallel. It uses the event loop to cleverly schedule tasks so that long-running operations don't freeze up the user interface. This is the fundamental secret that allows the modern web to feel so fast and interactive. Now that we understand how JavaScript manages time, we're ready to see how it uses that power to interact with the world around it. I'll see you in the next explainer.